Okay, for number 3, we need to find the Taylor series for f of x equals 1 over x, and we're going to center it at a equals 1. So we'll call it the Taylor series formula. We have the sum always from 0 to infinity. So we have the nth derivative of the function at a. We have x minus a to the n all over n factorial. So that's our general Taylor series formula. So let's just do that using the information that was given to us here. So we're going to need to write out a few terms though, because we're going to have to see what the derivatives look like for this function. So our f of x is going to be 1 over x, and our a is equal to 1. So let's just write out some terms here. So the first thing I'm going to do is write out a couple of the f terms. So we're going to do f of 1, f prime of 1, f double prime of 1, and see if we can figure out a pattern. So these are going to be this term in the first 3 terms of the Taylor series. Well, f of 1 is just 1 because we have 1 over x. F prime of 1, so the derivative of 1 over x is negative 1 over x squared. And if we plug in 1, we're going to get negative 1. Let me write these over here. So we have 1 over x, negative 1 over x squared. So the next term would be 2 over x cubed. Because if we bring the negative 2 down, it would cancel out the negative, but we'd have a 2 still. So now we get 2, because remember we're plugging in 1 for x still. Okay, so what you can see what's happening here, excuse me, what's happening here is that we're alternating, and as soon as we get past here, the next term, think about what you do when you take the derivative. You're going to move the number down again. We're going to move a 3 down. We're going to move 4 down. We're going to move 5 down. This is going to be multiplying by 3 and multiplying by 4. So this is a factorial sequence. And so this is like 0 factorial, 1 factorial, 2 factorial. The next one would have been 3 times 2 times 1, so 3 factorial. And we're alternating. So the nth derivative at 1 is really just an alternating factorial. So this is negative 1 to the n factorial. The rest of this we don't have to figure out, we can just plug in things. So that means our series now our derivative sequence ended up being negative 1 to the n factorial. Now our a is 1, so this becomes x minus 1 to the n. And we have n factorial on the bottom. So our n factorials cancel out here. And we just get our series as negative 1 to the n, x minus 1 to the n. So this is our Taylor series. If you notice, what we're missing is we don't have an interval of convergence, or what our radius of convergence is. Well, I mean, this one should be relatively obvious because this function is very simple. We only have one thing that could really even affect the radius of convergence, which is x minus 1 to the n. Remember that this is creating a geometric series when you plug in anything for x, because all you're doing is then having a number that you're raising to the n. And a geometric series has to converge if the number is between negative 1 and 1. Now, we can test this, though, by using the ratio test as well. Either way is fine. So think about it, what it means for a geometric series. So we know that x minus 1, the absolute value of x minus 1, I should say, has to be less than 1. We also have to check the endpoints, theoretically. So what this means here is that x is in between what? So this is a radius of 1 that's shifted over to the right. So x can be anywhere between 0 and 2 to solve that inequality. So we have this. So actually, the question just asked for the radius, so the radius of that is clearly 1. But if you wanted to figure out the actual interval, we would just have to check what happens if you use 0, or what happens if you use 2. If you plug in 0, you get negative 1 to the n times negative 1 to the n. Okay, so that is just 1, because negative 1 to the n times negative 1 to the n, they always cancel each other out to be 1. The sum of 1 is divergent, because you just have 1 added to itself infinitely many times. So this is indeed less than, so 0 doesn't work. So is 2 a bracket or parentheses? Well, either way, because when you plug in 2 here, you get 1 to the n. Alright, 1 to the n is nothing, so we just have negative 1 to the n, and we just have an alternating series. We're adding negative 1, 1, negative 1, 1, negative 1, 1. That doesn't converge either, so these are both parentheses. But our radius there is 1.